The probability of an event is written P of E, and it's read the probability of E. In example 4.9, we are asked to find the probability that the die comes up an even number. In general, P of E, probability of an event, is equal to the number of events divided by the total number of outcome. We call it NS, number in the sample space. Let's look at the sample space. We have 6 outcomes when the die is rolled once. Out of those 6 outcomes, 3 of them, 2, 4, and 6, are even outcomes. Now, the probability of coming up with an even outcome when the die is rolled once is 3 over 6, which is 0.50 or 50%. The special addition rule. When 2 events are mutually exclusive, P of A or B is equal to P of A plus P of B. Similarly, if we have 3 events that are mutually exclusive, the probability of at least one occurs is equal to the sum of their individual probabilities. P of A or B or C is equal to P of A plus P of B plus P of C. The special addition rule can be applied to solve this problem. Remember, you have a relative frequency. By definition, the relative frequency is a percent because it's the frequency divided by the number of data values. Now, what we're looking for is the probability that X is largely between 100 and 499. So it's 100 and 499 inclusive. What does that mean? It means that we have to take this part of the table. It's the probability of D or E or F. And that's how we call those events. Now, that probability is equal to P of D, which is 0.149, plus P of E, which is 0.077, plus P of F, which is 0.106. And the total is 0.332 or 33.2%. This problem deals with the age of senators. Remember that we have 100 senators and they give you different events. Now, they say use the table and F over N rule to find P of S. P of S is the event that the senator is under 70 years old. So P of S is P of X below 70, strictly less than 70. And this is the part of the graph. So it's going to be 32 plus 33 plus 12 divided by the number of senators, which is 100. So that probability is 77 over 100, which is 77%, 0.77. express S in terms of ABC. So S will be the sum of the senators under 50, A, plus the senators in their 50s, B, plus the senators in their 60s, C. To determine the probability of A, we're going to divide 12, which represents the number of senators under 50, divided by 100, or 0.12. Now, for B, probability that the senator in his or her 50s will be 33 divided by 100, or 0.33, and so on and so forth. For C, it'll be 32 over 100, or 0.32%. Now for the last part, we need to use the special addition rule from part B and C. P of S will be equal to P of A plus P of B plus P of C. Now P of S will be equal to P of A, which is 0.12, plus P of B, which is 0.33, plus P of C, which is 0.32. So P of S is equal to 0.77, or 77%. Both answers are the same. The tabular method at first just verified and confirmed the formula.